Hey, good morning, everybody. Once again, welcome to this workshop. My name is Sujal Das. I manage marketing in Metronome, and with me is Bapi Vinakoda. He leads our academia research program as well as all of the software and tools around it. So the two of us will get us started today. And then we'll have a couple of keynotes, and then we'll soon jump into the labs, which is the core of the workshops today.
Complete integrated packages. I always say it's sort of like getting an open source package and saying, make all, and once it's made, you can actually do something with it. It does something useful, and then you can go in and modify, rather than just here's a bunch of bits and maybe you can do something with it. So it's a big focus of the company, and it's the path that we continue delivering on.
You know about network virtualization, so I don't have to describe it, but the problem, which is a new problem, is that in every single host, you may now have 50 virtual networks. 50 different policies needing to be attached to virtual machines and containers that are co-located in a host.
I would like to just get ourselves sort of moving on what it is that actually is making the engine inside here. I'll be talking later with some of the labs again about the low-level detail. You can ignore me if you really want to, if you're interested in the very, very high level of things, how to program in P4 and so on. But I will tell you all about how the engine goes, how many cylinders it's got, how fast it goes, and why it goes fast, in some sense, and help you understand why it goes well.
Okay, so without further ado, if you can fire up your Programmer Studios, if they aren't running yet, you can follow along. I'm calling this the P4 Lab project. There's a large number of chip families and variants there. These IR graphs are generated from that intermediate representation. Remember the diagram where P4 gets compiled to the intermediate representation and from then compiled to the firmware. So you can actually go and click on these graphs to jump around in the code. And this visualizes for us the pass graph and ingress graph.
Right, so let's get cracking. Great. So here is our header definition, ExLand. You can see it's got a 32-bit tag, and as it encapsulates equivalent to VLAN, it's got the 16-bit ether type to identify the next header down the line. Okay. So right adjacent to the Ethernet header, we're going to paste in the ExLand header, and it's pretty much as easy as that.
Okay, so lab 3, I said we're going to make use of this primitive action construct in P4 to provide the hook for calling our filter function. So from the P4 perspective, this filter func becomes a named action like any other that we can call, and we're just going to plug that into our P4 source.
For those of you who haven't met me yet, my name is Chris Telfer. I work at Metronome, but for the purposes of this talk, you may call me the Gavin Imposter. So now in Hello World, we're going to change the decal spec. We're going to change the assignment of this program, the memory that we're assigning these variables to. Instead of just putting them in CTM and having one copy per thread per ME, we're actually going to add the keyword export and then scope parentheses island.
Behind the curtains, though, what does give me a packet mean? What does do a statistics operation mean? Well, we have this command push pull fabric that is tying the islands together, that's tying the microengines together. There's a bus within each island, but there's a switch fabric actually between the islands. So you're getting a bit getting your hands really dirty at this point. And actually, we get your hands really, really dirty right at the end of the next lab if you get that far.
So what we've been talking about here in the last 5 labs was different ways to actually attack the data plane.
As you can see, the company has plenty of really talented engineers who are very interested in engaging at a deep level. So please use the material, download it, interact with the company, and contribute back to the community. And in closing, if we could thank our instructors, I think they did a wonderful job for 8 hours today. So if you guys could stand up, all the gray shirts, stand up, and thank you. And we're done. Thank you.
I found this conference very interesting since I'm a systems and networking professor, and using an intelligent NIC in order to enhance the performance and security of the systems that I research is critical. And so this hands-on workshop gave us a very good idea on how to take our research to the next level.
When you have some hands-on sessions, it just gives you so much more understanding of the technology. And
like the event was really good, especially the demo session. So we get our hands-on on how to use like P4 and on metronome platform. The iNIC is really powerful and will help server deliver a high performance network to virtual machines.
I attended to get an idea about what P4 programming is all about, and I had a very good foundation on the P4 programming here at the Netronome P4CDevCon. And I definitely learned a lot, and I also saw how much of research is going into this area and how particularly Netronome is well placed in being part of many of these experiments with OVS, OpenFlow, and in research across universities in various areas of networking, including security, OpenFlow, and NFP and SDN.
There's the functionality NIC today. It's not zero in the base NICs. They do a lot. So that's the starting point, and then that span all the way up to doing much more offload with the Netronome processors and software. So I think there's a lot to explore there.